Okay, now we're going to do practice quest number 2 for 6.4 to 6.6. Okay, so number 1, this is quest number 2, pre-quest number 2, says convert to rectangular coordinates. So we have 4, 201, that's r and theta, and we're going to change that into x and y. Okay? So remember, x equals r cosine theta, and y equals r sine theta. So that's it. That's all there is to it. This takes about 2 seconds. So 4 cosine 201, negative 3.73, and 4 sine 201, which is negative 1.43. And that's it. That's the answer. That's all there is to it. Now, skip down to number 4. That was number 1. Skip down to number 4, because it starts out with the same 3 words, convert to rectangular. So we have 6 CIS 12, and we're going to convert that to x plus yi. So we're still going to find x and y, just like we did up here. But because there's an I in this problem, we have to have an I in our answer. So instead of writing it like an ordered pair, we're going to write it this way. But we're going to find x and y exactly the same way. So x equals 6 cosine 12, and y equals 6 sine 12. So typing in on my calculator, 6 cosine 12, 5.87, and 6 sine 12, 1.25. And that's it. So there's number 1 and there's number 4. We did them exactly the same way. The only difference is the way we wrote our answer, and we took our clue from the problem itself. If it's an ordered pair, answer is an ordered pair. If it's a number with an I in it, the answer is going to be a number with an I in it. Perfect. Now we're going to do 2 and 3 together because they are the same. 2 says convert this point into polar coordinates. So that means take the x and the y that you've been given and change it into an r and a theta. All right? So here we go. I'm going to draw a picture of this. Over 5 up 2, and I'm going to find r, and I'm going to find theta. So to find r, I'll square the first one, square the second one, add them together, and take the square root. So r is root 29. Just do the Pythagorean theorem. Now, here's angle A. I got to find that angle, so I know that tangent of that angle equals 2/5. So the angle itself is going to be second tangent 2/5. Tangent is opposite over adjacent, so 2 over 5. That's tan A, so I need to get A by itself. So I'll second tangent 2/5. And second tangent 2/5 gives me 21.8. So this guy is 21.80, which means my purple angle will be 180 minus 21. See where it is? So it's less than 180. It's 21 degrees less than 180. So my purple angle is 158.20. And there are the polar coordinates for problem number 2. Now, problem number 3 is exactly the same. Look at the first 3 words of problem number 2, convert to polar. Look at the first 3 words of problem number 3, convert to polar. We're doing exactly the same thing. The difference is this is an ordered pair, so my answer is an ordered pair. This is a number with an I, so my answer is going to be a number with an I. Okay, but I'm still finding R and theta. I still got to find R and theta. This is still X and Y. There's an understood 1 there. So I'm going to graph this over 3 up 1, over 3 up 1. This is R, and this will be theta again. So to find R, I'll square the first one, square the second one, add them up. R is root 10. Now I need to find this angle inside the triangle. So I will say tangent of A is 1/3. I put that negative in there. I didn't mean to confuse you. Don't worry about it. So the tangent is 1/3. So A is going to be second tangent 1/3. Which is 18.43. So this little angle right here is 18.43. So what's your theta? Your theta is going to be 180 minus that, 161.57. And that is the answer to question 4. So this was the answer to question 2, or wait, this is 3, I'm sorry, this is 3. This is the answer to number 3. This is the answer to number 2. Notice that the math was exactly the same. The only thing that was different was the way we wrote our answer. And hopefully you're taking good notes so that you will remember what's what when you go to take your answer, or write your answer. Okay, so turn the page. Now we're on to number 5. Number 5 says, I'll convert to a polar equation. Super simple. Easiest problem on the test. We know X is R cosine theta, and Y is R sine theta. So I'm just going to plug in R cosine theta here, R sine theta here, and this is the answer. Done. Took about 2 seconds to do that problem. Remember, always X equals R cosine theta, and Y equals R sine theta. All right, now we're going to convert to a rectangular equation, and this is a little bit harder. More steps for sure. So step 1, rewrite cosine theta in terms of its definition. So its definition is X over R. Now, I've said this before. These came from your gold sheet memorization way back in the first semester. If you've lost the gold sheet or can't find it, you need to get your book out and go back and find the definitions, the circular definitions for all of your functions, because you need to know them. Okay, or at least you need to have them in your notes so that you can find them when you need them. So cosine is X over R. Now, every time you do this, no matter what the function is, this will be different depending on what the function is. Cosine happens to be x over r. But every time you're going to have a fraction, and you're going to want to get rid of the denominator. So we're going to multiply by r. So we have r squared equals 2x. Then we remember from that triangle that we have used over and over and over again that x squared plus y squared equals r squared. So r squared, I'm going to substitute in x squared plus y squared in place of the r squared. This gets substituted in right here, and this is the answer to the question. This is your rectangular equation. Notice the variables are all x's and y's. All right, we're ready for number 6 now. And this is the problem where we're going to take our two numbers that are in trigonometric or polar form, and we are going to multiply them and divide them. When we multiply them, we're going to multiply the r's. Remember, these are the r's, these are the thetas. We're going to multiply the r's, so we get 50. And we're going to add the thetas, so we get 130. Done. You multiply the r's, add the angles. Now, in the division problem, you do the same thing, only you divide the r's and subtract the angles. So when I divide the r's, I get 10 divided by 5, which is 2. 10 divided by 5. And then when I subtract, I get negative 10. Well, this happened to us before. When you cannot have a number less than 0. You can't have an angle less than 0. So to make that angle positive, we simply find its positive coterminal angle, and we do that by adding 360. If you drew a negative 10-degree angle, that would be drawn in the same place as a positive 350. To change the angle, you simply add 360. And that is the answer to question B. Okay. Now we're ready for the big giant problem where we have to do several things. So we're going to start with 2 minus, this is number 8. Okay, I just did 7. So this is 8. And I did say, okay, I think I'm caught up. I hope I haven't skipped one. 2 minus 2i to the 6th power. 2 minus 2i to the 6th power. Now, this is x and y. So the first thing we're going to do is change this into our trigonometric form. So we'll draw 2 minus 2i. So over 2, down 2. We'll do the Pythagorean theorem, or square the first one, square the second one, add them together and take the square root. So this is the square root of 8. Now, I'm not going to reduce that, and I would suggest you not either. I know some of you are having a heck of a time getting some of this typed in on your calculator, and it's going to be easier if you just leave it as the square root of 8. So for the time being, I know it's 2 root 2. If you absolutely can't help yourself, go ahead and make it 2 root 2, but you're going to regret it later. You're going to have to deal with it later. I'm just going to leave it square root of 8. This is not my answer. I would never put this down in the answer blank, but it's not my answer. I'm working my way toward the answer. So my r is root 8. And now I need my theta, which is this right here. So I'm going to find my a. I know that the tangent of a is 2 over 2, 2 over 2, or 1. By the way, when those match, hopefully you've done enough of this that you remember that's going to be a 45-degree angle. But if you don't remember that, you are going to second tangent 1, and it's going to say 45 degrees. Theta, however, the purple angle, is not 45 degrees. The purple angle, look at it now, is going to be 315 degrees. Because all the way around is 360, but we only got to here. So 315 and 45 would be the whole 360. This is not the answer. This is what you are going to raise to the 6th power. We still have to do this. We haven't done this yet. So now we're going to take our root 8 to the 6th power. Remember, you raise this to the power, and then we're going to multiply our angle times the power. So de Moivre's theorem says, take the radius to the power, take the angle times the power. Okay? So now I'm going to take the square root of 8, and I'm going to raise it to the 6th power. And you should get 512. Now remember, when you press the square root of 8, a parenthesis comes in. Close that parenthesis and then raise it to the 6th power. So the square root of 8 to the 6th power gives me 512. All right, now what is 315 times 6? I don't know, but it's going to be way too big. 1890. Now, this is essentially the answer right here, but that angle is way too big. So remember how to shrink it down? To shrink it down, you have to keep subtracting 360s until you can't subtract anymore. So if I subtract 360, it's still too big. I'm just going to keep subtracting 360s. And it finally comes down to 90. And that is the answer to the question. A lot of work there, lots of steps. Remember de Moivre's theorem, when you got to raise it to a power, you take the radius to the power, and you take the angle times the power. And then we just shrink this down till I got down low enough by subtracting 360s. Some of you will think of other ways to do that, and that's fine. Get it down to 90. You got to get it eventually down to 90. Okay. Now we got our plotting. So we're going to plot point A. This is number 9. Point A is 5, 7 pi over 6. Now again, your graph paper is in degrees. So we'll probably want to rethink that. It's a radian measure. So 5, here we go. Pi is 180. Divided by 6 is 30, times 7 is 210. Now, if you can't do that in your head, that's fine. You have a calculator, type it in. 180 divided by 6 is 30 times 7 is 210. So I'm going to plot 5 comma 210. Now, the 210, this is the 180 line here. So this is the 210 line right here for me. You've got 210 labeled on yours. So you're going to come out the fifth circle on the 210 line and call that point A. So point A is the fifth circle out on the 210 line. And then B is negative 3, 270. Now you can't plot a negative, so you're going to have to change it to a positive. You cannot get on the negative third circle. That just doesn't work. So we're going to think of it as positive 3, and then our angle goes the opposite way. So it goes 180 degrees difference. This one's really easy to see. 270 would be straight down. If you have to go the opposite, you're going to go straight up, 90. 270 minus 180. You change your angle by 180 degrees. So it becomes 90. So we're on the 90 line, third circle out. There is point B. Number 10 says we're going to graph R equals 2 minus 3 cosine theta. Now, I went through this before. I'll go through it one more time. Your window, theta min is 0, theta max is 360, theta step is 5. Please don't change that. Set your window that way. X min, negative 5, X max, positive 5, X scale, 1. Do the same for Y. X and Y are the same. That is the way your calculator window should be set up. And if it is, you should have absolutely no problem sketching what I asked you to sketch. So here we go. Go to Y equals, clear out any old equations you have in there, and type in 2 minus 3 cosine theta. Remembering that theta is your variable button right next to alpha right under mode. So type in 2 minus 3 cosine theta, hit graph, and you get a beautiful little limacon. That looks like that. So you're just going to sketch that the very best that you can. Notice that it goes clear to the end of your graph, so it goes clear out to 5. Notice that the little interior loop is one big. On your axes, you've got hash marks showing the scale, 1 unit. So that little interior loop is 1 unit. So when you transfer it, I know it won't be as perfect as on the calculator, but make sure the size is right. And that's it for practice quest number 2. Good job.